So we look at this question 2019, 2020. We are giving a matrix. So you can see our matrix is in bracket here. This is 3 by 3 matrix. We have 3 rows and then it have 3 columns. This is row, this is column. So when you want to find the determinant of A by expanding the first row, so when it said first row means we have to follow the instruction. Sometimes they will give you expanding the determinant first row, second row, third row. They have 6 ways of doing that. Expanding by first row, expanding by second row or third row, or maybe expanding by first column, second column or third column. So they will have difference, but answer will still same, just working difference only. So when you are doing expanding by first row, means our formula here it will be determinant of A equals to A11. So because first row what means element 11 time this is cofactor 11 plus element 12 cofactor 12 plus element 13 cofactor 13. So cofactor also equals to plus or minus for minor. So for cofactor 11 it will be positive minus 11. But for cofactor 12 it will be negative. Okay, so cofactor 13 is positive for minus 13. Okay, so minus is what? Minus is going to cancel row 1, column 1. We are going to find the determinant for this. What is minus? Minus is going to cancel first row, second column. So you're going to do the determinant for this. And minus 13. So you're going to do determinant for this. So cofactor is positive, negative, minus. Either positive, negative, look at the location. Here is positive, negative, positive, negative, positive, negative, positive, negative, positive. So we back to our questions here. So when I'm doing first row, the determinant of A is equals to A11, means element, which is 2. Then we're going to do minus A12. A12 is element of first row, second column, which is 3. Then minus plus A13, 0. So how can I do this minus for a row faster? You can see I will going to cancel for the first one, which is 1, 1, 1, row 1, first column. So inside here I can see I get 0, 4, 2, 1. So I can do it very fast for entire row. 1, 1, 1, 2, 1, 3 by you can see, looking at here, by copy paste to the second entry here, copy paste this, and then the first one, the first vertical things we're going to put at the last. So it will be 0, 2. Okay, so this is how we call it in our entry in here, and then this is how they add out, and then copy paste. So what is the entry that empty here? We will refer to the vertical things that we cross on first column, which is negative 5, 0, negative 5, 0. Okay, so for second step, we're going to find this determinant of 2 by 2, which is we're going to multiply AD minus BC. So we put back bracket, AD is 0, minus BC is 8. So that is the difference between minor. Minor we will write in modulus form. So AD, which is negative 5, minus BC is 0. So for this part is 0. So finally we get negative 5. So the concept here is, the first one they will see how you expand, how you find your determinant using first row. Then get to your answer. Okay? Okay, so we continue. Now we're going to find the cofactor, the adjoint for the matrix. Okay, so we go for the concept first. If I want to find the adjoint of the matrix, I need cofactor transpose. So when I want to find the cofactor, means I need to find out for every entry plus or minus or is minor. Then going to transpose it. So first of all, I want to find its cofactor first. Alright, I perform the cofactor first. So for cofactor, matrix A, so I put a big bracket here because for every entry I am going to do their minor. So for A11 here is a positive minor, A12 negative minor, A13 positive minor. So for row 2, A21 here is negative minor, positive and negative. Then this one is positive minor, negative, positive. So this is my cofactor. Cofactor is equals to either positive minor or negative minor. Then I'm going to put our entries here. What is the determinant for this? Okay, so for this 1, so I will close row 1, column 1. I left 0, 4, 2, 1. So I can do it very fast. 4, 1, copy here, and then 0, 2, in, out. And then we see the vertical things there that we cross over is negative 5, 0, negative 5, 0. Then I will repeat. Repeat for row 2. So when I repeat for this position, which is row 2, column 1, I will get 3, 0, 2, 1. So copy paste 0, 1, and then 3, 2 going to the left behind here. So this is why my in, out, copy and paste. So what is vertical here? So vertical here is 2 and 0. Okay, then we continue again for row 3. So 3, 1 means I'm doing for this part, cancelling row 3 and column 1. Then we will left here 3, 0, 0, 4. Then copy paste, in, out. The vertical numbers that haven't cancelled is 2, negative 5. So we'll take the vertical number which haven't cancelled. So not this 0, sorry, 0 already cancelled. Okay, then we're going to figure it out. What's the answer? Okay, so doing our AD minus BC. So 0 minus 8. This will give us negative 8. And then this one, negative 5. Negative, negative become positive 5. Then this one, negative 10 minus 0. So negative 10. Here, 3. In front here got negative, so negative 3. Then for this, 2, so positive. Then for this, 4. 4 minus 0. So 4 got in front here got negative, become negative 4. Here, 3 times 4, 12. 12 minus 0 is 12. And then this one, 8 minus 0. So negative 8. And then this one is 0 minus negative 15 become positive 15. So this is our cofactor. And then I'm going to do the adjoint. So adjoint A will equals to cofactor and transpose. So transpose means row will become column, yang melintang akan jadi menegak. So negative 8, 5, negative 10, negative 3, 2, negative 4, 12, negative 8, 15. So this is how we get our adjoint. And after we calculate our adjoint, we have to hence find our inverse. So when we have this wording hence, because when we want to find our inverse, we have 3 methods. From here we have 3 methods. We can use adjoint method, we can use ERO, or we can use properties. So for this question, when you say hence means we are going to use the information before this, which is adjoint. So for this A inverse, we are going to solve by using adjoint. So other methods we are not going to accept. So we only accept for adjoint because question already said hence. So in order to use our adjoint to find A inverse, our formula will be A inverse equals to 1 over determinant of A, then adjoint A. So our determinant of A already found in question 1, which is negative 1. Then adjoint A we already found in just now. And then we multiply in our negative 1 here to find our A inverse. So this is how we do our part B. So what is important concept here? The concept here will be how we're going to find our cofactor and getting to the answer. Then our adjoint here is our question asked us to do, and we solve our A inverse by using adjoint method. So this is the concept and this is the answer. Okay, so we continue question C here. So you see what they ask us to do here. They said please solve for the equation where AX will equals to B, means our metric A times our unknown metric X will equals to this answer. So by using the answer obtained in part B just now, means the answer of A inverse, we have to find out what is our unknown metric here. So when you have AX equals to B, we have to time A inverse at the front, and then A inverse at the B here. Here we'll get our identity. When A inverse times A will get identity, this is our properties from our matrix. Then identity times with metric X will get still back metric X. So in order to solve this, in order to find this metric X, we need to figure out A inverse times with B. So just now my answer of A inverse is this. So I take down my A inverse answer. And the metric B here is 1, 2, 2. So here they will give us multiplication to come out this answer. Okay, so that's the concept and answer. So bear in mind in multiplication, when you multiply in front, then we have to go for in front because multiplication AB doesn't same with BA. Because in multiplication, the first metric we use row, the second metric we use column. So when you inverse the order, it will use the row of B and then column for A. It doesn't same. So that's why I show for you when I want to find X matrix here, means unknown matrix here, uh, I have to find out one by one. I cannot just move like algebraic. This is not algebraic, this is matrices. So you have to go in one by one. What's your properties? How you get to the X? And then this part is how's the corresponding part for right hand side. So this is negative 12. Okay, so multiplication of matrices you can do by your box. You can see clearly where it is row. That is 3 row times 1 column. Because first matrix will take by row, second matrix will take by column. So this is my row, the first row, second row, and then third row. And then for the second matrix, we take column, means we have one column only, 1, 2, 2. So how to multiply? We will, the first entry with first here 8 plus 6 minus 24. So that's we go for negative 10 here. So continue negative 5, then negative 4, then plus 16. So I might make this bigger so that I have space to write it. So make it a bigger column. So -5, -4 plus 16. You'll get 7. Then 10 plus 8, then minus 30. So you'll get -12. So this is how you get. So this is the way to help us to see what is your row and what's your column easily when you're using the box. Okay, means in front here with in front, middle and middle, and then at the last here with the last multiplication.